This is a number game with only 2 rules. A child can learn it in 1 minute. But watch what it does. Start at 27 and the chain runs for 111 steps. Start at 837,799 and the chain runs for 524 steps. They keep getting longer, and by the end of this video, I will show you the longest chain anyone has ever found. 1,348 steps. So stay with me and let's start at the beginning. First, we need 2 words. Even numbers and odd numbers. Here are 6 blocks. Let's split them into 2 equal groups. 3 blocks here and 3 blocks over here. They split perfectly with nothing left over. So 6 is even. Now here are 5 blocks. 2 blocks here and 2 blocks over here. And 1 block is left over. So 5 is odd. Even means the blocks split perfectly. Odd means 1 block is always left over. Now for the first rule. If the number is even, cut the number in half. 6 blocks become 3 blocks. 10 becomes 5. 16 becomes 8. Now for the second rule. If the number is odd, multiply by 3 and then add 1. Let's try 5. We take 5 blocks 3 times over. That gives us 15 blocks. Now we add 1 more block. 15 plus 1 is 16. So 5 becomes 16. Notice what happened. The even rule makes numbers smaller. The odd rule makes numbers bigger. And then you just repeat again and again. Let's play with 6. 6 is even, so we cut 6 in half. That gives 3. 3 is odd, so 3 becomes 10. 10 is even, so 10 becomes 5. 5 is odd, so 5 becomes 16. 16 is even, so 16 becomes 8. Cut it in half again and we get 4. Half of 4 is 2. Half of 2 is 1. We landed on 1 in 8 steps. Once you reach 1, the game stops. Now let's try 7. 7 is odd, so 7 becomes 22. 22 is even, so it becomes 11. 11 is odd, so it jumps up to 34. Then 17 and then 52. 52 is the highest this chain ever reaches. After that, it comes back down. 26, 13, 40, 20, 10, 5. And then 16, 8, 4, 2, 1. 7 took 16 steps. 6 only took 8. So the starting number really matters. Let's collect what we know so far. 1 needs no steps at all. 2 takes 1 step. 3 takes 7 steps. 4 takes 2 steps. 5 takes 5 steps. 6 takes 8 steps. 7 takes 16 steps. Look how much those numbers jump around. 4 is bigger than 3, but it finishes much faster. There is no simple pattern here at all. Now let's try 27. It looks just as easy. But this one climbs, and it climbs again, and keeps on climbing. All the way up to 9,232. That is 341 times bigger than where it began. Surely it can never come back down. but it does. It falls all the way to 1 after 111 steps. If you're enjoying this, a like really helps. And do subscribe because it gets much stranger from here. So people went hunting for longer chains. And they kept finding them. 871 takes 178 steps. And it climbs to 190,000. Look what that does to our graph. 27 has almost disappeared at the bottom. Next, 6,171. 261 steps, climbing to nearly 1 million. The graph has to shrink again. Next, 77,031. 350 steps, climbing to almost 22 million. And now the big one, 837,799. 524 steps, and it climbs to nearly 3 billion. Remember that number started under 1 million. It grew more than 3,000 times bigger. And it still ended up at 1. And the hunt kept going. 8,400,511. That chain runs for 685 steps. Then 63,728,127. 949 steps. Every time we looked further, we found a longer chain. But how do you search through billions of numbers? You would be waiting for years. So mathematicians looked at the patterns they already knew and found 3 clever shortcuts. Shortcut 1: skip every even number. Even numbers just halve into something smaller, and every smaller number was already checked. That removes half of all the work. Shortcut 2: you do not need to reach 1. You only need the chain to drop below where it started, because everything below has already been tested. Shortcut 3 is the best one. Take any number that leaves a remainder of 1 when divided by 4. Numbers like 5 or 9 or 13. Every one of those drops below its starting point in exactly 3 steps. 5 goes to 16, then 8, then 4. And 4 is smaller than 5, so we can stop. 9 goes to 28, then 14, then 7. And 7 is smaller than 9, so we can stop there too. That is always true, and it can be proven. So all of those numbers can be skipped as well. Now only one number in 4 has to be checked at all. With those shortcuts, the computers went hunting. And here is what they found. The longest chain in the first trillion numbers. It starts at 989 billion, 345 million, 275,647. That chain runs for 1,348 steps. It climbs to more than 1,000 million. And then, just like 6 did, and just like 27 did, it falls all the way back down to 1. Today we have tested every number up to 300 quintillion. That is more than the grains of sand on every beach on Earth. Every single one came back to 1. But testing is not the same as proving. Nobody can show that it works for every number forever. This puzzle is called the Collatz conjecture. It has been unsolved for almost 90 years. 2 simple rules. A game that a child can play. And the smartest people on Earth still cannot explain it. Maybe one day that person will be you.